Hi everyone, this is Ramakrishnan. I have been very intrigued by how large language models seem to have gotten better at reasoning over the last year or two. And so I thought it would be useful to describe some of the ideas that have led to these improvements. Before we get started, I have a couple of quick disclaimers. The first one is that I will not define the term reasoning. It's a complex umbrella term, it has a lot of aspects to it. So rather than define it, let's just do this. Whenever you see that word, just think of how you use it in sort of normal everyday conversation. And I think that's going to be good enough. So that's the first caveat. The second caveat is that whenever an LLM solves a problem that a human would solve by what we think of as reasoning, I will refer to what the LLM does as sort of quote unquote reasoning, just as a convenient label. I'm not implying anything deeper. I'm not saying that it's like actually doing human like reasoning or any such thing. Okay, I'm just using it as a label. So just keep that in mind. Okay, so let's get started. Now we will start with a complex logic question that I think hopefully you will all agree with me requires reasoning. So here is the question. Take a moment to just read through it, but don't read through it too closely. It's kind of a scary, difficult question. So a princess is as old as the prince will be when the princess is twice as old as the prince was when the prince's age was half the sum of their present age. And what's the age of the prince and princess? Assume everything is positive integers. Okay. I'm first of all, I'm really glad that this question didn't show up in any of my exams, in high school or even college for that matter. Now, I chose this question because it clearly seems to require reasoning. I can't imagine that a human would actually solve it without doing some kind of reasoning. So it's probably a good thing to sort of ask an LLM to do to see if it has any sort of reasoning ability. And again, just to reiterate, you don't need to solve this to understand the rest of this deck. I literally put it in here just as an example of what looks like a hard thing for an LLM to try to reason through. Okay, and I got this from OpenAI had this in one of their tweets, so that's where I got this question from. Okay, so LLMs used to struggle with these kinds of questions. And so why don't we see what actually happens if we give this problem to good old GPT 3.5, okay? So I literally cut and paste this as a prompt for GPT 3.5, and this is what GPT 3.5 produces as an answer. It says there is no valid solution to this problem along with a bunch of other stuff. Turns out this is just completely wrong. So if I were to give, a grade to GPT 3.5, I would basically give it a failing grade. I would give it an F, okay? Now, as LLMs have gotten bigger, they have gotten better at questions like these. So let's try to give the same question to GPT-4o, which is a much, much more recent model. I think the GPT-4 family is supposed to be maybe roughly 10 times as big as the GPT 3.5 model. So it's certainly a bigger model. I'm sure a much more training sophistication and data went into it, but let's give it a shot. Now, this is what GPT-4 comes up with. After lots of output, the final answer it produces is that the only positive solution is princess 16 years, prince 12 years. And actually, this is a correct solution. This is a single correct solution, but it's not all the solutions. And I'm clearly saying provide all solutions to this question. Okay. So, I mean, I would probably give it a B, a grade of B for GPT-4's performance, 4O's performance. Certainly not an A because it missed all the other possible solutions. Okay. So this is sort of what's going on in terms of just the LLMs getting bigger and getting better at solving these kinds of questions. So of course, the natural question here is, can we actually build a special purpose LLM or LLMs for being really good just at reasoning? Okay. Can it be special purpose just for reasoning? And the answer turns out to be yes. And over the past year, many so-called reasoning LLMs have been released. By the way, sometimes these reasoning LLMs are referred to as large reasoning models, LRMs, and many of the LLM vendors have released these models. OpenAI has a bunch of them. Claude 3.7 Sonnet has a thinking mode. DeepSeek, of course, famously released DeepSeek R1, a reasoning model, I think in January of this year. Google Gemini 2.5 series, Grok 3 has a think mode, and so on and so forth. Okay, and again, just to make sure that to reiterate the fact that I'm using reasoning as a label, that's why I have it in these air quotes. Okay, so let's give our problem to two of these so-called reasoning LLMs, We'll give it to OpenAI O3 and DeepSeek R1, one after the other, and see what happens. So I cut and paste this prompt into O3, okay, O3, and then it thinks for 36 seconds, and then it proceeds to then write out the final answer, which is, let x equals current age of the prince, y equals current age of the princess, which I think you will agree is a promising algebraic start. And then it goes on for a whole bunch of pages, and then finally the answer it produces is that the prince is 6m, princess is 8m, where m is all positive integers, okay? And then it gives a bunch of commentary around it as well. Well, the amazing thing here is that this is actually the right answer. Okay, so kudos to GPT O3. I'm sorry, OpenAI O3. It cracked the problem. It gets the gold medal, so to speak. So it's really wonderful. Now let's give this problem to DeepSeek R1. I actually have DeepSeek running on my phone, so I cut and paste the prompt into the prompt window here, and then I toggled on this DeepThink R1, which is basically the reasoning model, and then I hit go, and then it thinks for actually a much longer time than O3 did. It thought for 4 seconds, and then there was several screens of output. Okay, just take my word for it. It's probably like 20, 30, 40 pages of 40 screens of output, something like that. And then it finally produces the right answer, which is 8m, 6m, positive integers m. Again, it gets the gold. So DeepSeek R1 solves this problem very convincingly. Okay, this is impressive, right? It's actually a very difficult problem. If you try to solve it yourself, you'll see what I mean. It is pretty hard. And so now the first response, right, one might have is that maybe this puzzle was actually in the training data somewhere, and the LLMs basically memorize the solution. That's certainly a possibility. Now, but if it were true, I would have probably expected GPT 3.5 to have answered it correctly, unless the training data was vastly different in the later models. I mean, the bottom line is we just don't know. Okay, so that is certainly one possibility, and I don't want to ignore that. But what else could have led to this, right? That's an interesting question, because a lot of research has been going on. So I think fundamentally, from what I can see, a few years ago, researchers discovered that if we provide examples of questions and answers with step-by-step reasoning, right? If we provide these examples of step-by-step reasoning in the prompt itself, two interesting things actually happens. The first interesting thing is that the LLM, when it generates the response, will actually generate step-by-step reasoning in its own response, okay? Just because we have provided some examples of it in the prompt, right? It'll sort of mimic that. The second and more interesting thing, frankly, is that the accuracy of the response actually improved, right, by doing this. So let's look at an example. Here is sort of a standard prompt, right? And basically we have, this is the question we want to ask the LLM. The cafeteria had 23 apples. If they used 20 to make lunch and bought 6 more, how many apples do they have? That's the question we want the LLM to answer. Now, before we ask the question, we give a question and an answer pair, right, as a sort of a nice, helpful example. And this idea of using examples in the prompt itself is called, it leverages something called in-context learning. If you're not familiar with it, just Google it, or I guess ask an LLM to explain it to you. Anyway, so this is the standard way we would do it, right? We just give a question and answer, and then the question that we want the LLM to answer, and hopefully it'll understand what's needed and produce the answer. Now, in this case, it actually gives you the wrong answer, okay? It just says 27, and it actually happens to be wrong. Now, let's compare this to a better prompt, sort of which shows the thing I've been describing so far, what researchers discovered. So this is a prompt where we have an example of step-by-step reasoning, okay? So before, the same question as before, but the answer is now different. Look at the stuff in blue. We say Roger started with 5 balls, 2 cans of 3 tennis balls, and each is 6 tennis balls. The total is 11, and so the answer is 11. Okay, so we give an example with these reasoning steps, the stuff in blue, and then look at how the model responds. It actually, okay, so what we did, this example has triggered the model to respond with reasoning in its response, and the answer ends up being correct as well. So this is literally as simple as that, right? You provide examples with reasoning, and somehow that makes the model, produce reasoning in its output and, have a higher chance of getting the right answer. So this strategy, which has become very famous now, is called chain of thought prompting, chain of thought, sometimes abbreviated to COT. right? This is called chain of thought prompting. And remarkably, if shortly after this was discovered, researchers discovered that even examples weren't actually strictly necessary. If you simply start the response, sort of prime the response with the phrase, let's think step by step, that was actually enough very often to get the LLM to generate reasoning steps in its response and, have the right answer, right? And so this is called zero shot chain of thought, by the way, just a piece of jargon to keep in mind. And the zero shot here, shot is just a synonym for the word example. It just happens to be something that's used in the literature. So zero shot means just zero examples chain of thought. Okay? Okay, so I think the big picture here is that chain of thought definitely helps improve performance on reasoning questions. And if you're curious about improvement metrics and such, there are many, many papers out there. Here is one paper that introduced the idea. If you look at figure 4 of this paper, you'll know what I'm talking about. Now, I think it's maybe useful to just pause for a second and ask ourselves, why does this chain of thought thing, why does it actually help? And I think there are, researchers have sort of thought a lot about this, and there's lots of stuff out there that's been written. But I find it sort of intuitively, if you think about how we humans solve these kinds of complex problems, right, particularly the things which involve multiple steps of reasoning, right, we obviously will do much better at these questions if we can actually work things out, like doodle on a scratch pad or something, rather than if someone saying, hey, you got to do it all in your head and just give me the answer. I'm not going to give you any paper to write on. It's obviously going to be much harder for us to do it. But if we actually have a piece of paper to, do some scribbling and doodling, we can probably do a better job of handling these questions. So maybe chain of thought is sort of like, basically gives LLMs that ability. Maybe that's what's going on here. Maybe that's what's going, true for LLMs, right? Again, I'm sorry for the anthropomorphizing here, but maybe something like that is going on, right? We just don't know for sure. Okay, so if adding chain of thought to just the prompt can make an LLM better at reasoning questions, it sort of suggests something very obvious as the next step, which is that, hey, maybe if we use chain of thought in just the training process itself, in how we actually build the LLM in the first place, maybe that'll result in even better performance, right? That's sort of the logical next question. And now let's recall how LLMs are actually built, okay? So if you take something like ChatGPT, ChatGPT was built from GPT-3, which is called the base model. And then it went from GPT-3 to ChatGPT using essentially two important steps: supervised fine-tuning and then reinforcement learning from human feedback. Now, if you're not super familiar with it, or perhaps you were familiar with it, but it's been a while, I have a quick refresher. You can see this short video on the Sloan website. It's, I think, about 20 minutes or something that sort of walks through this process by which ChatGPT was built. Or you can read an explainer that I posted on LinkedIn a couple of years ago as well. Okay. So what we will do is we will infuse this chain of thought idea into these two steps. Okay. Okay. Now, the next several slides, I've relied heavily on DeepSeek's very nice and detailed technical report on how they built their R1 reasoning model. And of course, to convey the key ideas and keep things non-technical, I've simplified many details. So if you want to learn more, please see the original DeepSeek report that I've linked to here, and other resources referenced, everywhere, and all across the deck in many places. Okay, we will first see how we can modify this supervised fine-tuning thing. Now, what is supervised fine-tuning? Again, quick refresher. Basically, what we do is we create lots of questions and high-quality answers, which are relevant to the particular task or the domain that we are working with. This could be hundreds, thousands of questions. And the key is that for every question that we have, we need to make sure the answer is really good, right? It's high quality. So here is an old example from the OpenAI blog, which is the question is explain the moon landing to a 6-year-old in a few sentences. And the high quality answer, something that a human wrote, was people went to the moon, they walked around, came back, and so on and so forth. Okay. So we basically create hundreds and thousands of questions and answers, high quality answers like this. And once we do that, we essentially feed the question to an LLM and then have it predict the answer, right? The right answer. And this this process of, sending in inputs, making predictions, and then using the right answer to sort of, update the weights the LLM in the right direction, that's basically supervised fine-tuning. Okay, now how can we infuse chain of thought into this process, right? That's the key question. So it's actually very simple when you think about it. what we need to do for supervised fine tuning is that we create questions and answers. So when we create these answers, how about we actually include reasoning steps in the answer, right? Because that's kind of what did the trick initially when researchers figured out chain of thought. So here is a standard question answer pair for supervised fine tuning, and then I'll show you in a second how this will change if you want to use chain of thought. So I just grabbed this question from the GSM 8K dataset. Julie is reading a 120-page book. Yesterday she was able to read blah, 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 and so on and so forth. How many pages should she read? This is the input, and then the answer is, say, 42, which is the right answer. So typically we just give this as the input and have the LLM predict this thing, 42 here. So instead of doing that, what we'll do is that we'll actually provide this chain of thought here. So we have a nice step-by-step reasoning thing here. Julie read 12 pages yesterday. Today she read twice as much, so that's 24. And in total, that's 36, and so on and so forth. And so, by the way, just notice a little typo here. There should be an equal to here, and I'll fix it before I post the slides. Sorry about that. Anyway, so you have the reasoning thing here along with the answer as before. And this is what's being used to train the LLM, right? The input goes into the LLM, and it needs to predict not just the output, but the whole reasoning and the output, okay? This is basically supervised fine-tuning with chain of thought. Now, once we do that, it turns out the LLM gets really much better at responding with reasoning steps whenever you ask it a question. So for example, here you have a question, answer the following question by reasoning step by step, and it has like some sort of a little question, and then the LLM basically comes up with a nice reasoning in its response, and then gives you the answer, okay? So chain of thought fine-tuning definitely helps. And it improves reasoning performance quite significantly. And again, if you want to learn more, I have a link here. If you want to sort of look at the metrics, look at the kinds of things, the kinds of tasks in which it actually leads to improvements, the size of the improvement, and all that good stuff. Okay. By the way, a quick jargon alert. This step-by-step reasoning thing we have been talking about here is sometimes referred to as reasoning traces in the literature. Okay, just FYI. Okay, now let's take a quick look at how reinforcement learning can be modified with the chain of thought idea. Now, what is reinforcement learning? Again, like a lightning refresher here. In this phase, we typically first collect lots of questions, and then we will send each question to the LLM, and then we'll have the LLM generate multiple responses, okay? So in this case, it has generated like a kind of a pretty bad response. It has generated a better response here. Let's say we have these two responses, and once we have these multiple responses from the LLM, what we do is that we have to figure out how well each response actually answers the original question. You will agree with me that this response is a very poor response to that question. So the rating we would give it is probably pretty bad, something like pretty close to 0, let's say. On the other hand, this question actually is a much nicer response to, this answer is a much nicer response to this question. So we'll probably give it a much better rating. Now, these ratings are called rewards, right? Just a piece of jargon. They are called rewards. And the way we actually calculate these rewards from these question-answer pairs is by using something called a reward model. But we actually don't need a reward model in the slides that follow, as it turns out. And so I'm just making a mention of it here just to let you know what it is. And if you want to sort of refresh your memory about the reward model, you can just see that video or the LinkedIn thing I referred to earlier, but you don't need to do it, okay? Because we will not need it in the slides that follow. So the key question is that, better answers will have higher rewards, i.e. higher ratings. And once these rewards are calculated, what we do is we take these reward numbers, right? And then we sort of use these numbers to nudge the LLM in the right direction so that in the future, the answers it produces will hopefully have higher ratings, right? We sort of nudge it in that direction. And this nudging business is basically called reinforcement learning, right? Hence the name. All right, so can we modify this whole process in some way to incorporate the chain of thought idea, like we did for supervised fine-tuning? Now, there are many ways to do this. We will just describe what DeepSeek did, and DeepSeek also focused on math and coding questions, and we will do the same thing as well, and I'll talk about why this assumption is actually useful in just a bit. Now, as before, we first collect lots of questions, but we also collect all the right answers for these questions as well. Then we feed each question to the LLM with a chain of thought prompt that encourages the LLM to basically show its work, right? To actually list out reasoning steps. So here is the prompt. It says, first think about the reasoning process in the mind and then provide the answer. And the reasoning steps and the final answer should be enclosed within think and answer tags respectively. By the way, this is literally the DeepSeek prompt that I got from that paper. I just slightly edited it. And so you can see here, first it says think about stuff and then provide the answer, right? So it's encouraging to think first. And then it says, whatever the response is, just split it into two. Split it into like the reasoning stuff, which is going to be enclosed in these think tags, and the final answer, which should be enclosed in the answer tag, right? And why we want the thing to split the response is just because it becomes a little easier for us to analyze what it produces a little later on, as you will see. So we do that. And with this prompt, now we attach the question, any question we have. Here is just a fun little question that I put in, solve this quadratic equation. And then we have the LLM generate multiple responses. And as you can see here, just to illustrate, I have these two responses where, it is doing some reasoning thing here, listing a bunch of reasoning stuff inside these think tags. And then it produces the final answer 1, which in fact is the right answer for this question, right? And just for fun, I created another response in which, it says this looks quadratic, but some blah, 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 something, a bunch of reasoning stuff going on, maybe wrong, we don't know. And then it produces the final answer. And this final answer is actually wrong. Okay, I just deliberately chose it to be wrong just to make a point. All right, we have that, these two responses. Then the question becomes, we need to calculate this reward for each of these responses as to how well it answers the question. Previously, I said we use something called a reward model. Here, we will not do that. We will do basically what DeepSeek did is as follows. They calculated the reward very simply by basically saying, look, we're going to check for two things. We're going to check to see if the answer is correct first. Now, this is where the math and coding thing comes in, because for math questions, we know the right answer, right? We have it. So we can easily check if it matches whatever the LLM came up with, right? And helpfully for us, the LLM has stuck its answer inside the answer tag. And so we can compare whatever is inside the answer tag with the right answer and say, yes, correct or incorrect. And similarly for coding questions, we can run the code and then we see if it passes test cases, okay? So we can check for correctness using this idea. And then we check for the presence of reasoning steps, meaning we literally check to see, hey, did it actually have any content inside think tags or not? Amazingly enough, we don't check if the reasoning is correct. So we just check to see, is there any reasoning? That's it, okay? So using these two things, we can calculate the reward pretty easily because it's kind of deterministic and sort of rule-based. No fancy stuff required. And if you want to see what DeepSeek did in more detail, just see this section of the paper. So once we do that, we can calculate the reward. And because here it provided some reasoning inside the think tags and it gave the right answer, I'm just giving it a reward of 1. And here, because it has some reasoning, it gets 0.5. But since the answer is wrong, it gets nothing there. So I'm just giving it 0.5, okay, just to make the point. So once we calculate these two numbers, as before, we take these numbers and nudge the LLM in the right direction, so it's more likely to produce the right answer in the future. And this nudging basically is reinforcement learning, and the DeepSeek folks did sort of a variation of this reinforcement learning algorithm, which you can read more about in 221 of the paper if you're interested. Okay, and that's basically how reasoning LLMs like DeepSeek R1 were built. So jargon alert again. When we do reinforcement learning, where we actually calculate the rewards using these sort of rules, simple rules, deterministic rules, this is referred to as reinforcement learning with verifiable rewards, or LVR in the literature, right? Just FYI. So, by the way, apart from what we have seen so far, reasoning performance can be improved by giving the LLM quote unquote more time to think. What I mean by that is, I'll give you a couple of examples of this idea. You can actually, for any given question, you can generate multiple responses, and then you can literally pick the most frequently generated response as the answer, okay? And this little simple technique is called self-consistency, and you can read more about it here. And this can be used for any LLM. It doesn't have to be a reasoning LLM. You can literally give it a question, generate, say, 10 responses, multiple responses, and then just count, the answers showing up in this thing, and take the most frequently given response as the answer. Now, there's no guarantee this is going to be correct, but what researchers have seen is that it actually improves the probability of actually finding the right answer, right? It's like a very simple thing to do. Another example of this idea of more time to think is that you can generate multiple responses, and then you can actually use a different model called a verifier model to pick like the best response from this set, as opposed to the most frequent response. And this is called like the best of n strategy. Now, you can see now why this idea of more time to think comes into play here, because whenever you have to generate multiple responses, the LLM is doing more work to answer your question. You're kind of giving it more time to think, right? That's sort of where it's coming from. Again, jargon alert. So when you give the LLM more time to think, this whole business is referred to as scaling test time compute or scaling inference time compute, because after you ask the question, as the LLM is doing its thing, you're basically doing more computation at that point in time when you generate, say, n responses. That's really where it's coming from. And by the way, this paper is actually a pretty nice, gives a nice overview of many of these techniques. So check it out if you're interested. So in summary, reasoning performance seems to have gotten better using three approaches. First, of course, is that we use this idea of chain of thought in the prompt itself. And second, when we train the model LLM, we actually can change the supervised fine-tuning so that the answers in the fine-tuning phase includes reasoning traces. And then we do reinforcement learning with verifiable rewards like we just saw. And then finally, after training, you can give the LLM just more time to think and do things like best of n. And I guess I just want to re-emphasize that even if you don't have access to like a reasoning LLM, right, doing just these two, right, just do chain of thought prompting, and if possible, have it generate multiple responses and pick like the most frequent one or whatever. These two things may help improve reasoning performance, right, even with a plain vanilla LLM. Now, final caveat, just because an LLM answers a complex reasoning question correctly, it doesn't really mean that it's going to answer some other reasoning question correctly, perhaps even a simpler one, right? There are lots of examples out there of LLMs getting complicated things right and simple things wrong, so just keep that in mind. My sort of, I guess, pragmatic view on this is that if you're working on with LLMs, reasoning LLMs for a particular task, for a particular business case, you have to essentially assemble task-specific question-answer data sets and then rigorously evaluate the LLM on how it performs on this data set to understand sort of its true performance characteristics. Okay, just remember that. As you might have guessed, we have barely scratched the surface of what's going on in the space. This is the DeepSeek paper that introduced their reasoning LLMs. And this article here, this Substack article, is actually a really nice overview of the main approaches. Check it out if you're curious. And then finally, if you want to sort of stay on top of the space, or at least track the space, Nathan Lambert, who's an AI researcher, has a nice Substack where he frequently posts about what's going on in the space. So that might be a nice way to sort of keep in touch with the latest and greatest stuff. I think that's all I had. Thank you so much for watching and reading. I hope you found that useful. Happy learning. Bye.